Hello friends, welcome back to another video on this channel. In today's video, I will show you guys my new creation, a DIY CNC XY plotter. Now this one is a bit more different than the others on the internet because I have actually completely custom built every bit of it. So as the title suggests, you do not need any 3D printers or any aluminum rails. So let's get started. So as you can see, it's already printing something. So by the time it's done, it will have printed another one. I already showed you guys the time lapse of it printing before. So let's get directly into the structure as well as how to build it. So obviously for the electronics, I have an Arduino Uno that is controlling two stepper motors. These are BY28J's unipolar motors. As you can see, I have one here. This is for this y axis, and one here on the x axis. Now if you are wondering, I said no aluminum rails, so what are these, you might ask. Actually what these are just some aluminum rods. The way I extracted these rods are actually from aluminum hangers, so cloth hangers. Basically I took them, I bent them up, and these are the long like the bottom long bits where you hang the clothes, these two rods. And these two rods here are actually the sides of them. So I actually took two hangers and I like cut them at the bottom. So these are those two hangers, and these are the two sides. So the little curved bit on the side which connects the whole thing, that triangle bit, that's that's this bit here that you see. Now for the actual platform, the way it is I have this Lego piece here. This is just a Lego like flat bit piece, and what I found is my hangers which I had, the rails basically fit perfectly into the holes of these Legos, so they are almost like it's sliding on it. As you can see, it works perfectly like that. Same here, I have another one on this side. What I did, I just took these little rails and I kind of like mangled the ends of them a little bit so that they became like almost like a bit jagged, and then I just like friction fit them onto the piece, and then I put this like another piece on to clamp it in, and then just put a tad bit of super glue in there to just finally finish them off. Same with this side. Now on this side you also need an extra pulley type system. So what I have is this end here. As you can see, the rods end up here, and onto them I have attached this little piece of Lego, if the camera focuses there. Now what I have done here is, what you need is, you need a little kind of a support. Sorry, you need a little bit of a support. So as you can see here, I have this long Lego post. The way it should be is that when it's actually the pen is plotting, like as you can see the pen is plotting, it should just slightly be above. But when the pen pulls up, the servo pushes the pen up, what you want it to just touch so that it supports it, as you can see here, and so the platform doesn't just completely bend down and the pen again ends up actually touching it. So for the platform, it's another thing on top of it, you want a little pulley type system. Ideally this would be rotating like on a bearing or something to allow this this bit of string here to just move, but I couldn't find something that would work, so I just ended up doing it like this. So as you can see, this string, it goes to this platform. This is the main plotting platform. As you can see here, the way it works is it's also just a few pieces of Lego that are fitted onto these rails. And what I have done is, onto them there are two L bracket type things, these bent up L's on both sides, this side as well as this side. And the way it is working is, basically I have this like pulley thing. If you're wondering what these are, this is just a BO wheel. So if you know those little cheap BO wheels you can buy for like small motors with the what I did to that, I took the part where you're supposed to put the motor, the BO motor in, those little yellow color BO motors you find, but that bit, if you see, it will almost resemble the shape of the stepper motor's prongs, but it doesn't fit perfectly. So what I did, I just took a little bit of a hot like soldering iron basically, and I just slightly moved slightly removed it so that it fits almost perfectly, friction fit it on, and then I just put a little bit of super glue in to fix it in. And this little this bit here is actually the tab like the cap of a medicine bottle. So if you buy one of those liquid medicine bottles, for example, you'll find these caps that go on top of it that give you the measure to see how much of the liquid you are taking out. So that's just two of those fitted onto these. and then basically the way it is done is that over here this one has this string roped onto it. This side is attached directly onto the platform, as you can see there. The other side moves around, goes through around the pulley, and then attaches on this side, so it can then pull it back and forth. For the pen mechanism, the way it is, I have a servo there, as you can see. That servo is pushing this little jig here. So the way it is that I have this the one of those, one side is this like cross, and then the plus, and then the other side is the Lego connector bit, this bit here. So I have those two connected to this piece of Lego here that I have then, so it can swivel up down a little, and then I have attached this piece of straight piece here, which is just super hot glued onto the pen, and the servo basically pushes it up to push the pen out of the way when it doesn't want it to plot. And when it wants to plot, it will just have this rubber band, as you can see, that just pulls the pen down and it pushes the pen to the paper, so it can then plot it successfully. Now I moved it a bit, so it's not perfect, this print, because I was moving it around, so it just like vibrated a little bit here and there. But other than that, this side rail, let's talk about that. So I have these two L brackets. These are standard L-shaped brackets. So I just shoved these rods into them both sides, and then I made sure that basically I put one of them in straight roughly with respect to this board here. This is just a piece of wood I have stuck everything onto. So I put one in, put this thing in, and then I put the second rod in, and I basically just attached one screw onto one of these posts little tightly, and then I just wiggle the other end around. As you can see, this is not straight onto it because I will still put one of them in, and then based on that I wiggled it around until to the point where it was moving almost freely inside it to get the alignment straight. Then I put the other screw in, so this bit was fixed, and then I took the other end and did the same thing. So like that you can get this such that the platform can move freely onto it. So for the this side's pulley, it's the same system. As you can see, I have the same thing here, string attached directly onto this bit. It goes around, it actually goes through it, but that's just the hole it's going through. It goes all the way around here, and then on this side I have this thing. Now what this is actually a makeshift pulley. So what I did, I took two bolts, like this is just a standard bolt. I believe this is a M6 bolt, but doesn't really matter. I took this, and then I basically put it inside this wood bit. As you can see, I then put two nuts and then interlock them together so that they are locked, and but the bit, it doesn't put any pressure on this top bit here. This is just a, basically what this is actually I had an old tank, remote control tank chassis lying around. Now in that tank, the thread bit, it actually goes on through these little pulley type things attached onto the plastic. So I just took that, and now it's working as a pulley here, and the bit then goes back around and goes through there. So that's basically it for physically making this. I would recommend one thing is that the pen you are using, it should ideally be a rolling ball pen like this one here, as you can see, because that these just work like beautifully with this, because when it's resting, as you saw, it is actually just resting on the tip of the pen. So if it's a like a rolling ball pen, what it does, it just allows it to move smoothly and freely. So that's it for this bit. Now let's talk about the electronics. The electronics for this is quite simple, obviously, just two steppers and a servo motor connected. So what you want is you have the Arduino Uno. Now the x-axis, which is going to be on this one here, as you can see, it's going on to this one. This bit goes into pins 2, 3, 4 and 5, and then the y-axis goes to A0, A1, A2 and A3. So these are the 4 pins it goes into. Now what I want you to do is just put them in wherever, like whichever orientation you feel like, and then we can test it later whether it's like done or not. So if it's the correct side, then we can say that okay, it's good. Otherwise we can just take the pin out and then flip the whole thing and put it back in, so it will just reverse the orientation, reverse the way it moves. But yeah, as you can see, it's done printing this. So this is, it's just printing this right now. Just this bit here, you can see it moved a little bit because of me shaking it around and colliding with it a little bit here and there. The servo goes on to pin number 11, by the way, and everything else is just powered via 5 volts. So this is a 5 volt rail. This side's also got this yellow bit going into this breadboard power rail thing, and it's just going into my custom power supply. This power supply I've used in quite a few of my previous videos. So just a custom thing I just built for this project. All it has is a 240 volt to 12 volt 6 volt DC converter here, step down, as well as AC to DC full bridge rectifier. And then I have this bit here. So as you can see now, for 12 volt power I just have it directly connected to this terminal here, which gives me 12 volt power onto this bit. And then for 5 volt power I have this 5 volt 5 amp constant current regulator. So that bit gives me 5 volts up to 5 amps out from here onto this. As you can see, I have these two jumper wires going into the breadboard. So yeah, that's basically it for this bit here. So that's the power supply powering the whole thing. Now obviously you will need to improvise a little. If you don't have something quite similar, so you might not have these hangers or something like that, do a little bit of improvising. But yeah, that's basically it for physically building the thing. I'll now go ahead and switch over to the computer and show you guys the software in complete detail. Okay, as you can see, I have switched over to the computer now. This is the software running on it. So we'll go through this first. What you need to do is over here in the description you'll find a zip folder of this. So if you'll open it up, you will see these few folders in it. Now what I want you to do is, first of all, go over here to this bit here. This is the this is the library that's running on the Arduino. This is actually the Gerbil library, but this has been converted to run on this was actually the Gerbil original Gerbil library uses those NEMA 17 bipolar motors. We are using BYJ. These are unipolar motors. So this has been converted to run this, and as well as the servo bit is also not in the original Gerbil code. So these were done separately. This, if you can just download it online, if you search up 28 BYJ servo Gerbil, you'll find this. That one has a little bit of a issue because while converting it, they actually made a bit of a problem here in this this full file here. If you open up, if you download it online, and if you open up this stepper one, this one, you'll actually see that if I find it, the stepper.c1, cannot find it for some reason here. There it is, went up. Anyways, if you open up this stepper.c1 here in the one which you just downloaded, you'll find that over here this line would be commented, like there will be two slashes here, which is not supposed to be there. That was a mistake which was made on this updated folder. This bit allows it to not compile and causes an error. So I have fixed this here. So if you download it from the description now and run it, it should work. But if you do end up downloading it from GitHub directly, just download it and then remove these two slashes on the stepper.c file here, and then go over here and click save, and that should be it. It should just allow to run. What you want to do is copy this bit from here, go to library. So if you go to your documents folder, you'll scroll down here, you'll find Arduino. Over here, you want to go to this libraries folder and just paste the Gerbil file here. As you can see, I have this pasted here, the whole file. This is also the updated one. So what you want to do then is open up the example. So you can go through the Arduino library and open up the right click the examples and open up Gerbil, but or you can just come here and do this and click on this Gerbil upload bit, this file. Now you want to upload this file directly onto your Arduino. That's it. There is no more changing on the Arduino. If you see, in fact, this file doesn't even have much. It just includes the Gerbil library. That's basically it. So you want to take this, upload it to your Arduino. As you can see, I'm using the Arduino Uno, I just said. So after doing that, your Arduino code is completed. You can now go ahead and go back to your bit with the you can go back here, and over here you'll find one more thing. You'll find this file here. If this is actually Universal G Code Center, as you can see, I have it running on the background here. So I just go ahead and close it. You will find that you can go over here, go to the bin and open this thing up. Once it's done loading, you can open it up. As you can see, now you'll close this, and over here you want to go to this machines file and go to setup wizard. Now this you just have to change your COM port. So as you can see, mine's on COM 7 only. So you can click connect here. It will automatically do its thing and connect up to the Arduinos directly. Now this only works on Arduino Mega, Uno. For some reason it doesn't work on the Mega. I have tried it, but your mileage may vary, I do not know. Anyways, moving down here, you can come over here, go to open settings file, Same in the downloaded bit, you would find, I go back here, you'll go here, and you'll find this firmware 2024, this one. This is the settings file. You want to open this, and you'll find this here. You want to click here, import, click next. Now this is where you'll test it, so just go ahead and do plus minus and see actually what your thing is doing, whether or not it's correctly moving in the plus and minus direction or not. If it is moving correctly, you are good. Otherwise, as I said, just reverse the pins physically. This reverse direction thing just doesn't work for some reason. Just physically reverse the pins and you should be good. Then click next. Here you want to grab a scale, click this plus bit here. You'll see what it's saying, it's moving. So as you can see, it's moving 1 millimeter. Now I just want to hit that there and actually see what it's moving in real life. So over here you'll see what is actually moving in millimeters, and after checking what it's moving in millimeters, you can just put that bit here in this and you can click update here to get that. Z-axis doesn't matter, we don't have a Z-axis. After that, you just want to go here, we don't have limit switches or homing or soft limits, so we can just click finish, and that's basically it. Now you'll be left with a bit of a window looking something like this. Over here you'll have this toolbox. This is what you are going to use to basically set to 0 and return to 0. So once you have happily made it to its 0 position, you can click this bit and set it current position as 0. Over here you can go to jog controller and you can actually physically move it. So here you can change things like how much you want it to move at the one click of the button. So if you do something like this, you can click plus X and it will move it that much. You can control it and see if it's doing as you like. Now once you're done playing around with it for a bit, you can go over here, click this, and this is where you'll upload your G code. Now don't worry, you're supposed to use a SVG, I know, but so these are some sample G codes that I have provided that you can use, but if you don't want to use these, you will do this here. So first of all, you want to use Inkscape. This you can just download Inkscape and then open up your SVG as you can see here. Now once you have opened up your SVG, you can just make the change. You can make your changes. If you have an image that you want to get traced, just open the image here, go to object here, path, sorry, click trace bitmap, and then here click apply. So that will make the SVG out of the image. Now once you have gotten your SVG file satisfactorily, you want to come over here, hit save. That will save your SVG. Once you're done with that, you'll go to this website here. This will also be linked there. This is going to convert your SVG to a G code. So you want to choose files, choose your SVG file. Once you have done that, as you can see, I have it open. You want to click settings here and you just want to go ahead and click import, choose the file. Same thing in the description, you'll find here this one. Open this and you can go ahead and click save. Now in settings, you'll find something similar to this, as you can see here. You can go ahead and close this, click this generate G code button, and you'll then get a G code of it instead of the SVG you had before. So as you can see, this is the coordinates of it, XYZ coordinates of the thing. Now once you're done with that, you want to come over here, hit this, go to sample designs, or you can open your G code, just click open, and as you can see, it will open up the G code like here. You can see it on the visualizer. Now sometimes it does this bit where it's actually not centered to the 0. So what you want to do is come over here to program, go ahead and rotate it, because my Y axis is the long axis, X is the smaller axis, and then I'll click here translate to 0. So this will bring it closer, and over here you can see the dimension. So you can see this would printed as 5 centimeters wide and 100 millimeters or 10 centimeters wide. So you can see that, and if it's out of your limits, you can, like, if this is bigger than actually what your machine can do, so you just come over here to Inkscape, select the whole thing, make it a bit more smaller, click save, and then regenerate the G code, and it will make it physically smaller here. Once you're done playing around with it, you are happy with the position as well as the size of it, you can then come over here, click this button here. This will just start the code, and you can just go ahead and it will just automatically do everything. So it will just follow the path, it will pull up the servo. Another thing, yes, I forgot to mention the servo itself. Now over here, if you go to settings, not this one, you'll find here tool off sequence and tool on sequence. So what this is this is setting the servo angles basically. So the way it's set up in mine is when it goes to 255, like, so the way we are doing it is in Gerbil, the way it's set is between 0 to 255 is actually your 0 to 180 of the servo scale. So in my case, it is 255 is basically the pen is fully down, and 25 is the pen fully up. So that's what I have set up here. You might want to change this. To just do this, you copy this bit here, hit copy, and then come over here to console. You can go ahead and just Control V, paste it. Now once you have pasted it, you can go ahead and play around with the angle a bit and see which angle makes it that the pen is fully up from the paper, and which angle makes it that the pen is down on the paper. And then take that and put this here in this tool off and tool on sequence, and then you can just save it, and you can just click here export and download the new file, and then you can go ahead and convert the SVGs to G code, and then put them here and go ahead and run the code. So yeah, that's basically it for today. I hope you guys enjoyed this video. If you did, please be sure to leave a like, subscribe, and I'll see you guys next time.